Hey everyone, this is Cody. In today's video, I'm going to be reviewing the IDAS NBZ-II dual narrowband oxygen-3 hydrogen alpha filter. The NBZ-II is the NBZ to replace them all. If you've watched this channel for a while, you'll know I started with the original IDAS NBX, which was an excellent dual narrowband filter, except that it suffered from star halos. Now the NBZ fixed that with its magical anti-haloing properties. After that, we got the NBZ-UHS, which stands for ultra high speed, and as its name suggests, it was excellent in fast telescopes with aggressive light cones. After that filter, we got the NB-12. That was a cheaper version of the NBZ, but it did require the use of a UV IR cut filter somewhere in the imaging train. After that, the NBZ-EX came out, and that was designed to be used at multiple focal ratios, from fast systems at f1.8 all the way up to infinity. The NBZ-II is designed to replace all of those. The NBZ-EX is usable from f1.8 to infinity, replacing the NBZ-UHS or ultra high speed filter. The NBZ-II is also usable from f1.8 to infinity. So why is it replacing the NBZ-EX? Well, it has narrower band passes than the NBZ-EX does. The hydrogen alpha band pass in the NBZ-II is 10 nanometers, and the oxygen-3 band pass is 8 nanometers, plus or minus 0.4 nanometers. So you're still getting that excellent performance at all those different focal ratios, from fast optics to slow optics, but you're also getting narrower band passes, so you're cutting out a little bit more of that light pollution with the NBZ-II. So it really does replace the entire previous line of NBZ filters. Let's look at the transmission of the oxygen-3 and hydrogen alpha bands in the NBZ-II, starting with the oxygen-3. In this simulated refractor OTA transmission graph, you can see at the 500.7 nanometer oxygen-3 band that the majority of focal ratios have excellent transmission. From about f2.4 and higher, you can see that the transmission is about 95%, which is just awesome. At f2, the transmission is still about 91, 92% or so, which is still really good. Going down to f1.7, you're still getting about 83% transmission of that band. And even with really fast camera lenses, f1.4, you're still getting about 65% transmission of the oxygen-3 band. So just wonderful performance from the NBZ-II in that main O3 band at 500.7 nanometers. The hydrogen alpha band at 656.3 nanometers also shows excellent transmission through the NBZ-II. At f2.4 and higher focal ratio, you can see the transmission is about 95%, just like the O3 band. At f2, it's still about 93% transmission, which is excellent. Going down to f1.7, you see that it's still about 83, 84% transmission of the H-alpha band. And then going down to f1.4, just like the O3 band, we see it's about 65% transmission. So the NBZ-II really can be used at a variety of focal ratios, which is pretty amazing. So you can use it with fast camera lenses or systems like the Celestron F2 RASA, or you can use it with telescopes that have slower focal ratios like a long focal length refractor or a Schmidt-Cassegrain. It's becoming more common for filter manufacturers to start including an optical quality report with each individual filter that they sell. IDAS is including these with the NBZ-II, which I think is a great touch. They have the substrate lot number on here and your two bands. So the oxygen-3 band here, the main band I should say, is transmitted at about 98% for my specific filter, which is pretty amazing. The hydrogen alpha band at 656.3 nanometers looks to be transmitted about 93%, which is really good. And then as I go up to about 657, 660 nanometers, that also goes up to about 98%. So this would be awesome for getting subtle hydrogen alpha details out of distant redshifted galaxies. Because as the light from those distant galaxies is redshifted, that hydrogen alpha band will move over, and I'll still pick that up at about 98% transmission, which is pretty incredible. So my NBZ-II will work great for distant redshifted galaxies, as well as objects that aren't redshifted too. Now I can talk about the filter's properties all I want, but I don't think there's anything quite like real results, so I'm gonna go ahead and do some imaging. Another cool thing that IDAS does is they list the substrate thickness of your filter right on the box. So this one is 2 millimeters thick, and the optical thickness is 0.67 millimeters. This is the distance that you will need to add to your imaging train to get to the proper back focus. Now, the back focus is calculated by taking the substrate thickness and dividing it by 3. That's going to give you the optical thickness. If you want to see why that's the case, be sure to check out my Back Focus 101 episode on how filters affect back focus, and I'll link to that in the description. So with all that said, there is a reason why I like the NBZ filter line so much, especially the NBZ-II, and that's because it checks all of the boxes that a dual narrowband filter should. The first box it checks is its transmission. 95% transmission of the main O3 band and 95% transmission of the H alpha band is quite impressive. Second, its transmission is high from f1.8 to infinity, which is pretty incredible that I could use this in a fast camera lens or telescope like my Celestron f2 Rasa 8, but I could also use it in all of my slower telescopes as well. So this filter could literally be used with every single telescope I own, which is awesome. Third is the size of the band passes. The hydrogen alpha band pass is 10 nanometers and the oxygen 3 band pass is 8 nanometers. So the filter isn't so narrow that it takes forever to gather that light, but it's also not wide enough to let in a lot of light pollution. So it really is kind of the ideal filter for imaging planetary nebula, emission nebula, and supernova remnants. Lastly, the filter has the same anti-star haloing technology that the previous versions of the NBZ had. It's pretty amazing that you can take an image at high speed and not see any star halos. So the NBZ-II really does check all the boxes that I think a dual narrowband filter should have. Alright everyone, well that wraps up my review of the IDAS NBZ-II. As always, I hope you found the review helpful and informative. I'll go ahead and post a link to the IDAS NBZ-II in the description, so if you're interested in checking it out further, you can. And as always, I hope you have a great day. Thanks so much for watching, and clear skies.